there are a wide variety of benefits that building information models provide, right? So if you look at this slide here, there are something like 20 or 25 different benefits that are out there. Of course, it's too small for you to read, right? But the point is there are a large number of benefits. Let me walk you through some of these benefits, and then we will connect them very briefly to lean construction. Okay. First of all, one of the reasons why there are delays on construction projects is that when the structures come up, once clients can actually see those structures visually, right, they then realize that they would like some changes made. It's very difficult for them to understand blueprints, but when they see the structure in real terms, that's when they decide that they would like some changes made. And as and when they recommend changes, that causes delays in the process and possibly increase in costs. Okay. So one way in which we can avoid these changes is to start building early on very realistic life-size digital models of these buildings that clients can explore so that they can actually minimize the extent to which they make changes later on. Okay. So let me show you, for instance, one example. This is a very simple walkthrough, right, of a metro rail underground station. Once you have a three-dimensional BIM model, it's just a question of plotting a route through the model and asking somebody to, or asking the computer to show you that route, right? And literally this can be done in a few seconds. Okay. And you can change these walkthroughs. You can have different kinds of walkthroughs that you play in your, that you create and you can play to determine whether the asset that you've built meets your specifications or not, or whether any changes are required. Okay. So these kinds of things do not require any computer graphics expertise, right? They're very simple interventions that can easily be undertaken once you have a building information model. Okay. So photorealistic rendering is one application of it. Okay. Second, you have an issue that plagues construction sites called clash detection. Okay, so very often what happens is you have civil components, structural components, and mechanical and electrical components. When the mechanical subcontractor is trying to erect a duct on site, suddenly they might find that there is actually a beam that is blocking where the duct is supposed to be. Now, this means you have to go back and you have to resolve, how do I reroute the duct, all of that. It takes time, it costs a little bit of money. Okay. What building information models can do is, because you're having architectural information, structural information, and mechanical information coming together on the same platform, you can actually run a very simple query where you can tell the model, or you can ask the model, you have all of these pieces of information that are on your platform, right? Are there any two elements, mechanical, electrical, civil, whatever, that share the same XYZ coordinates? And if so, that's a clash. Please list them out for me. So the computer very quickly looks at all the information you've put into the model and says, here's all the clashes that we've detected, right? Here are 27 different elements which are sharing the same XYZ coordinates. And you can do this before even a cubic millimeter of concrete has been poured, before you have started construction. So prior to construction, you can very quickly sit down and say, here are some clashes. Let's resolve them. Let me reroute this beam there. Let me reroute that duct there. Let me reroute that pipe there, and come up with what we call good for construction or clash-free drawings, so that when you actually start constructing, there are no issues with regards to clashes, and construction proceeds at a very even and fast pace. So this ability to do clash detection, right, and review designs to see if your designs actually meet the standards that you expect is something that building information modeling can provide, right? Again, a very big benefit of building information modeling. You can do all kinds of analysis on your building, because now you have an intelligent three-dimensional model of the building. You can say, here is the latitude and longitude of where it is going to be located. And based on that, you can simulate the sun path and determine what are parameters like indoor air quality, indoor air temperature, thermal comfort, right? The computer can very simply and very easily simulate all of these parameters, right? So you can then analyze the sustainability of your building, analyze your design, and make changes if you want to, again, virtually. Again, this is possible because all information, geometric information, the kind of glazing that you have, the thickness of the walls, the insulating material, all that information is available on that single BIM platform. Moving on, once you start construction, constructability is a very important issue, right? It pertains to how easily can you actually construct what you want to construct. This is not as easy as it sounds, because in some cases you have a lot of very big machinery that you have to maneuver through a constrained site. You have a number of crews that are working simultaneously, and you'll have to ensure that they are working in a manner in which They are all able to work productively together. So constructability and the planning of your construction operations becomes critical. Okay. Now, again, this can be simulated ahead of time. You can simulate various construction sequences. Okay. And based on that, you can pick out what you feel is an optimal construction sequence. And this is what we call 4D model. Okay. So let me show you a very simple 4D model. Okay. On the left, I'm trying to simulate what's called a bottoms up construction, a lot of excavation and then things come up bottom to top. And on the right, I have something called a top down construction of a station, right? I build the top floor slab and then I start going to layers below. Now, both of these are different construction sequences that I can simulate. How am I simulating this? I'm building something called a 4D model where I take the 3D structure, but instead of showing it to you in one shot, I attach the structure with a schedule and I run a timeliner, and based on the schedule, items show up when they are actually installed. So it gives you the feel of actually seeing an animated construction sequence. Okay. Again, this takes barely a few minutes to do once you have a schedule and the model. And what you're able to do is understand and compare between various construction sequences. Okay. So that's another use of building information model. You can also use building information modeling for cost estimating. You can, for instance, directly take out quantities from the building information model, right? You have a 3D model with all the information. How difficult is it going to be to figure out how many columns you have and what their dimensions are? And computers can generally do this without making the kinds of errors that humans would, right? So for quantity estimation, for cost estimation, you can directly get these out of the building information model that you build. And if you need two-dimensional drawings, because that's what works on site, you can always print out sections. Take your 3D model, cut a section, print out a 2D diagram, and give it to people on site, or isometric views, or whatever it is you want. Okay. So there are a number of these kinds of uses of building information modeling on site. There are a few others. I'm not going to go into these in very much detail. But for instance, just to quickly mention, earlier when you wanted to fabricate something, you would actually send information to a fabricator. That person will put that information into their fabrication machine. It would fabricate something, then that component will be transported to your site. And sometimes there are errors in terms of what has been fabricated and what you require. Here, information goes directly from the building information model into the fabricator's machine. So what comes out has to be precisely what you had in your drawing. So again, BIM can be used for fabrication. Safety, again, being able to visualize your construction site, visualize operations, understanding where safety nets and harnesses might be required, understanding where and when edge protection might be required. Again, a lot of safety-based analysis can be done using building information model. Right? So the point here is that having an integrated 3D model that allows people to coordinate and put all their information together in one repository is likely to have considerable benefits in allowing you to coordinate better, minimize errors, and do things faster on site. Right? So building information modeling is very useful in that manner. Okay. Now, a question that you might have is, yes, this is all qualitative. Theoretically, it is useful. Practically, right, is building information modeling useful? Right? Can we measure? Okay. So people at SciFi, Center for Integrated Facilities Engineering at Stanford University some time ago, said, yes, let's measure. Let's measure, are there any quantitative improvements on safety, on cost, on schedule, on sustainability? Let's actually go ahead and measure. And they looked at certain BIM implementations and through careful measurements, actually found data like this. Let me not go through all of these, but look at some at the bottom. Look at rework volume, 0. There is no rework because you have essentially done what's called virtual design and construction. Ahead of time, you have detected all your clashes, you've asked your design doubts, people understand the optimal construction sequence. There is absolutely no rework, right, when BIM was implemented on a project. Field generated requests for information come down by 99%, right, because there are fewer questions that are answered in the field, right? Cost conformance is very, very high, right, and so on and so forth. So quantitatively, BIM does have benefits. And if you're wondering, are these benefits only in America? Are there benefits in India? We have done studies in India as well, right? And we also get similar results, right? So there are lots of improvements that accrue due to BIM that also lead to time savings and cost savings. Okay, so BIM can certainly help improve the performance on your construction sites.